Okay, let's look at example 7. The displacement of an oscillating object as a function of time is shown in the figure beside. From the graph, determine for these oscillations the amplitude, the period, and the frequency, the angular frequency, the equation of displacement, equation of velocity, and equation of acceleration as a function of time. Okay, so here we are given a graph of y against t. So y is the displacement, t is the time. So y against displacement. So in any graph we can extract two information. So ada dua information yang kita boleh ambil. First of all, kalau kita ada displacement graph, okay, so the value here represent the value for amplitude. And then daripada graph di sini kita boleh dapatkan the value for period. So period is a one complete cycle. The time taken for one complete cycle. So from here, okay, starting there and then one complete cycle is to here. So this is the value for the period. Okay, so the value for the period is 0.8 second. So ada dua value dah yang kita boleh dapatkan. First is the amplitude, which is 15 centimeter. Second one is period 0.8 second. Okay, then we can jawab soalan first one. Okay, dia minta adalah the amplitude. So amplitude kita boleh terus dapatkan, which is 15 centimeter. And then second one, we want to find the period. Okay, so period kan kita boleh dapatkan, which is 0.8 second. And then next one, we want to find the frequency. So frequency, formula dia adalah 1 over t. So 1 over 0.8, which is equal to 1.25 Hz. Okay, next one, we want to find the angular frequency. So angular frequency is the same. Okay, it's another name for angular velocity. Okay, ini adalah nama lain untuk angular velocity, which is what we want right now is omega. Okay, so omega, keluarkan formula. Kita ada dua formula, either 2 pi f ataupun 2 pi over t. So mana-mana je lah kita boleh gunakan. Dan you masukkan 1.25 kalau kita gunakan 2 pi f, which is equal to 2.5 pi radian per second. Okay, next one we want to determine the equation of displacement as a function of time. Okay, so equation of displacement against time as a function of time. Okay, general equation dia adalah y is equal to a sin omega t. So kita masukkan value a dan omega sahaja. So value a kita tadi adalah 15 second, right? Sorry, not 15 second, 15 centimeter. Okay, so kita convert dia kepada meter. Let's convert it to meter, which is 0.15 sin omega. Omega 2.5 pi t. Okay, so this is the equation of y as a function of time. Okay, next one. Next one, we want to find the equation of velocity and acceleration as a function of time. So this one, we want to find velocity, apa dia punya equation, and then acceleration, apa dia punya equation. Okay, so before this, okay, we need to derive this equation by differentiating the previous equation, which is kita differentiate what? We differentiate the displacement against displacement time graph. Displacement time equation, sorry, not graph. Okay, so kita differentiate lah, which is kita differentiate 0.15 sin 2.5 pi t. So we differentiate this one darab dengan the value for omega. Kita akan dapat 0.375 pi, and then differentiate sin, kita akan dapat cos, and then the rest you just salin semula lah, because the value for pi doesn't change. the value for pi pula, the value for omega. This one is value for omega. Okay, next one, we want to find the acceleration pula. So acceleration, kita perlu differentiate the equation for velocity. So differentiate d over dt. Velocity equation dia this one, 0.375 pi cos 2.5 pi t. So differentiate this one dengan omega, kita akan dapat 0.9375 pi square. And then you differentiate cos, kamu akan dapat negative sign. And then the rest you just salin semula lah, 2.5 pi t. And then kita susun bagi dia cantik, which is negative tu kita letak di depan. Negative 0.9375 pi square sine 2.5 pi t. Okay, so this will be the equation for acceleration, this one for velocity, and this one for displacement.